geobyte.
Try to read it clearly. Asking like this. A car is moving on a horizontal curved road with a radius. Radius of curvature of the curved road is 50 meters. The approximate maximum speed of a car will be if friction between the tires and road is, that means coefficient of friction, mu equal to 0.234. G value given 10 meter second power minus 2. Let me write it clearly. It is minus 2. Okay. Here, you know, by the time the car is traveling in the curved path, centripetal force should be balanced by the frictional force for avoiding the overturning of the car. For that, the centrifugal force, that is mr omega square, must be balanced by the frictional force. That frictional force is equal to mu mg. Okay. So here m cancel. R omega square is equal to mu g. From this, omega square equal to mu g by r, mu g by r. Then omega equal to एक minute somewhere mr omega square equal to mu mg. Okay, mu mg, m is cancelling. R omega square equal to mu g. You're asked to decide what? You're asked to decide the approximate maximum speed, right? Here it is angular speed. In terms of the same can be written in terms of linear velocity. This is one relation that is absolutely correct. There is no mistake in that. It is mv square by r is equal to mu mg in terms of linear velocity. Here m value is cancelling. V square equal to mu rg. V equal to root under mu rg. It is equal to root under mu value given 0.34 multiplied by 50 multiplied by g value 10. You simplify this value for getting the velocity approximately 17 meter per second. That is the answer. Look at the option D. Option D is absolutely correct. Understood clearly? Yes. Then look at the another important problem. Look at that problem. It is asking like this. A block of mass m slides down, slides down the plane inclined at an angle 30 degrees with an acceleration g by 4. It is like this. This is the inclined plane. This is the base. This is the inclined plane. The angle of the inclined plane, theta given 30 degrees. 30 degrees. This is the block. This is the block. The self weight of the block is acting vertically downwards. It is sliding down. This is the direction of motion. Look at the direction of motion. This is the direction of motion. The frictional force always acting parallel to the plane but opposite to direction of motion. Okay. Now look at the normal reaction. This is the normal reaction. N. Then look at the angle between the mg and normal reaction. This is 30 degrees. Then this is mg cos 30 degrees and this is mg sin 30 degrees. Okay. Then the value of coefficient of friction. You are asked to decide coefficient of kinetic friction. Coefficient of kinetic friction mu k or simply mu equal to how much? Okay. For that you need to resolve the forces. Here n must be equal to mg cos 30 degrees And body is moving down means mg sin 30 degrees minus frictional force must be equal to mass times the acceleration. mg sin 30 1 by 2 minus frictional force mu n equal to m times the acceleration is g by 4. G by 4. Here it is mg by 2 minus mu n. N equal to mg cos 30. mg cos 30 value I am directly writing root 3 by 2 is equal to mg by mg by 4. mg by 4. Now look at the numerator part. mg 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 is cancelling. Finally it is 1 by 2 minus root 3 by 2 mu is equal to g by g cancelling 1 by 4. 1 by 4. From that I can write that 1 minus root 3 by 2, 1 minus 2 is cancelling on both sides. Take minute. It can be written like this. It is 1 minus, here this 2 cancelling, for writing here 2. So 1 minus root 3 mu is equal to 1 by 2. 1 by 2. From this 1 minus 1 by 2 is equal to root 3 mu, or root 3 mu equal to 1 by 2. Then coefficient of friction equal to 1 by 2 root 3. That is the answer. Look at the option. Option B is absolutely correct. Understood clearly? Yes. Similarly, let us take the another most important problem. Look at the problem. It is asking like this. Consider a block kept on an inclined plane. The plane angle given with respect to base 45 degrees as shown in figure. If the force required to just push it up the inclined plane is 2 times the force required to just prevent it from sliding down. The relation between the force required for just for pushing up the block and just for stopping the sliding down of the block given. If I say F2 be the force required for pushing up the block and F1 be the force required for just stopping the block at that location, right? Or F1 is the force required just for preventing the sliding down of the object, then F2 equal to 2 times the F1. That condition is given. Okay, F1 is the force required for preventing the sliding down of the object, whereas F2 be the force required for pushing up the block. Okay, the coefficient of friction between the block and inclined plane mu is how much? You are asked to decide coefficient of friction. Okay, for that let us take the another slide. First let us take the force required, the force required for preventing the sliding down of the block. For that case, look at the base. This is the plane, angle between them is given 45 degrees. Listen carefully. This is the block. This is the block. Let me mark the center of gravity. Through that, weight is acting vertically downwards. Look at the contact surface. Normal to that contact surface, normal reaction is developing like this. This is the normal reaction. Then this is the 45 degrees. Here mg is acting at an angle 45 degrees with respect to normal reaction line. Therefore, it is developing two component of weights mg cos 45 degrees and this is the mg sin 45 degrees. Here let F1 be the force required for preventing sliding down of the object. Sliding down means this is the direction of motion. Then the frictional force is acting in this direction. Okay. Now let us resolve the forces. Resolving forces. Listen carefully. Very, very important problem. Resolving forces perpendicular to plane. Perpendicular to plane. Now, perpendicular to plane, n must be equal to mg cos 45 degrees. It is equal to mg cos 45 degrees 1 by root 2. Finally, it is mg by root 2 is the n value. Okay. Next, resolving the forces. Resolving the forces parallel to plane. Parallel to plane. Parallel to plane. Here the F1 is acting towards upside plus frictional force that must be equal to mg sin 45 degrees. F1 plus frictional force Ff equal to mu n is equal to mg sin 45 degrees. F1 plus mu, look at the n value. Normal reaction is mg by root 2. It is equal to mg by root 2 because sin 45 degrees is equal to cos 45 degrees, that is equal to root 2 by 2, 1 by root 2. Then force F1, right, it is for just for preventing the sliding down of the object is equal to mg by root 2 minus mu mg by root 2. It is finally, I can write mg by root 2 outside into 1 minus mu. That is the force required just for preventing the sliding down of the object. Okay. Next, force required. Force required for pushing up the block. Okay. For that again, let us take the base, plane. Angle between the base and plane is 45 degrees. Is it 45 degrees? Yes, correct. 45 degrees. Then look at the block. This is the block. Through the center of gravity, the self weight is acting vertically downwards. This is the normal reaction n mg cos 45 degrees mg sin 45 degrees. No, here the force is applied. The force is applied in this direction for having the direction of motion in this direction of motion. Since the block is moving upwards, frictional force acting opposite that one. This is the frictional force. Okay. Now resolving the forces. Resolving the forces perpendicular to plane. Perpendicular to plane. Perpendicular to plane n equal to mg cos 45 degrees, it is equal to mg by root 2. Similarly, resolving the forces, resolving the forces, resolving the forces parallel to plane, parallel to plane, parallel to plane, F2 is acting in the opposite direction. It must be equal to mg sine 45 degrees plus frictional force. But F2 is given. The condition, what is the F2? F2 equal to 2F1. 2F1. It is 2F1 is equal to mg sine 45 degrees plus frictional force mu into n. N is mg by root 2. mg by root 2. 2 into what is the F1 value? This is the F1. mg by root 2 into 1 minus mu. Mg by root 2 into 1 minus mu is equal to mg by root 2 because sine 45 degrees 1 by root 2 plus mu mg by root 2. So on both sides mg by root 2, mg by root 2, mg by root 2. Finally it is 2 into 1 minus mu is equal to mu is equal to mu is equal to 1 minute 1 plus mu 2 into 1 minus, right? It is 1 plus mu 1 plus mu. From that I can write that 2 minus 2 mu is equal to 1 plus mu 1 plus mu. From this how can you write 3 mu equal to 2 minus 1 1 mu equal to 1 by 3. What is the 1 by 3 value? 0.33. That is the coefficient of friction. I hope all of you clearly understood. Understood or not? Yes. Look at the options. Look at the options. Option A itself is absolutely correct. Okay? No? Yes. Look at the another important problem. Try to read this problem. It is asking like this. As per given figure, a weightless pulley P is attached on a double inclined frictionless surface. Look at the weightless pulley and these two are smooth surfaces, frictionless surfaces, smooth surfaces. Okay, na? Next, the tension in the string will be, you're asked to decide the tension, of course, G value given. The string, since the same string is connected to both blocks, as long as the string is remaining same, the tension remaining same, that is T. Okay. Now, look at the left side block mass M1 is placed in one plane, left side plane angle is theta 1. Other side mass is M2 is placed on the other plane, angle is theta 2 30 degrees, theta 1 60 degrees. Okay. For that, first let us decide the acceleration. Here, acceleration equal to, try to remember this formula, m1g sine theta 1 minus m2g sine theta 2 dividing by m1 plus m2. Try to remember this formula. M1 is how much? M1 is 4 kg. 4 1, right? 4 kg g into sine 60 degrees, right? Minus m2 1 kg g into sine 30 degrees dividing by m1 plus m2, 4 plus 1. So 4 into g value 10 sin 60 root 3 by 2 minus 10 into 1 by 2 dividing by 5. It is 2 times 20 root 3, 20 root 3 minus 5 dividing by 5. It is equal to 4 root 3 minus 1. That is the acceleration. Okay. Now look at the right diagram once again. I am considering the left side block. The left side block is like this. This is the left side surface making an angle 30 degrees. Look at the block. Listen carefully. This is a block. Here, this is the M2 we are assuming. M2 into G, and this is the normal reaction line. Listen carefully. Normal reaction line is like this. It is 30 degrees. Then it is mg cos 30 degrees, and this is the mg sin 30 degrees. The string is connected like this, maintaining the tension T. Okay. Now, since the uh, right body is accelerating, this T minus mg sin 30 must be equal to mass times the, here mass is m2, mass times the acceleration, mass times the acceleration, T minus mg, m means m2, m2 1, g 10 sin 30 1 by 2 is equal to 1 into a value. A value is 4 root 3 minus 1, 4 root 3 minus 1. So T minus 5 is equal to 4 root 3 minus 1. From this I can write that T equal to 4 root 3 minus 1 plus 5. It is equal to T equal to 4 root 3 plus 4. Therefore tension equal to 4 into root 3 plus 1. That is the tension developed in the string. Understood clearly? This is the string. Now look at the options. 4 root 3 plus 1. 4 root 3 plus 1. 4 into whole into root 3 plus 1. 4 into root 3 plus 1. Option B is absolutely correct. Understood clearly? Yes.
Geobyte.